Hello everyone and welcome back to another Universe Sandbox video, and today we're going to be doing part 3 of our most recent alternate reality solar system from evolving it from birth to death. So if you've not seen the previous two parts, definitely go ahead and check those out first. But without further ado, if you remember last episode, we lost a lot of objects. We can still see the remains of Planet X over here, the only thing that has managed to hold on. We lost a lot of the inner planets. We've lost Uranus, we've lost the 5th giant, they're gone. We lost the 6th giant, that gone. That was the whole cause of all of this chaos as well. Jupiter and Saturn worked as a team to eject absolutely everything out of the solar system completely. The 6th giant got slung in the inner solar system and it destroyed Mercury, Venus and Earth. They all got ejected. So we remain with Feya, Mars and Ceres as the only full-size planets left in the inner solar system. All of them are pretty cold at the moment, so there's no potential life candidates in the system at this moment in time. Jupiter, Saturn, their orbits have they've had slight changes, but they're still pretty dominant there. And then we have Neptune on the outer skirts over here that managed to avoid all of the chaos, being the last ice giant out in the distance there, so it didn't have too much problems. So it's been able to hold on. The dwarf planets and the smaller and the far out planets as well, like Pluto, because I can call Pluto a planet in this scenario, and Eris. Those worlds have managed to survive just in the depths as well, so just waiting to hopefully one day be warmed up in the future, which is probably what we'll get to today. And then the only other planet remaining is Planet X, the Super Earth, all the way in the depths since here. And as you can see, last episode it got ejected. I mean, we can land on the surface here, so kind of similar to the thumbnail of the last video. It's even worse than that thumbnail now. We are so far away. Look, there's Nemesis, the sun. There is absolutely nothing going here. We put the goggles on off, you can barely see the sun at all. It is that far away, so it's not good. You can see the Nemesis over there as well. So this is completely gone from the solar system. You can see the darkness is just, I mean, this thing's distance now is 400 plus. I mean, this is just completely at it. I mean, I doubt it's ever going to return properly. I mean, you can see its orbit there. I reckon Nemesis will just eventually clear it out now. It's in that bad region. So without that all said and done, let's continue with the evolution of this solar system. And as you can see, there's still changes. You know, the Nemesis, or you know, that last episode did cause some real damage and instability. So the outer orbits is still wobbling a bit. I mean, of course, with the gas giants in there, the Planet X orbit is definitely not going to have a good day ever again. Then the inner solar system, hopefully, is fully, you know, is for the most part okay now. So Mars and Feya are the two to watch out for. Their orbits are crossing each other. If we just have a pause here. There you go, you can see the plane. The orbital plane is different, but those orbits do have a very similar meeting point if they get in the right place at the right time. So we may catch that out at some point today. Mars and Feya having a close encounter, if not a collision, which could be very interesting. As you can see here, for instance, that was a close call in this region here. I mean, if we look together, can you see Feya from Mars? I reckon you probably could. You can. You can see it in the distance there. Turn the goggles on and off. You can see it there. There's Feya. And I'm sure you can see Mars from Feya as well. If we look down, where's Mars? There it is in the distance, so it is visible. You can see it there. So a very, very close encounter. Oh yeah. Interesting stuff. Very, very interesting. So that all said and done as well. Let's continue with the evolution now. So we can see the system's still wobbling. The instability of the outer solar system really is pretty haunting now. As you can see, look at the wobble of some of those. But that could be responsible for Pluto and Eris' bigger presences out there as well. Also having a bit of a wobble. I think that's mainly Jupiter and Saturn, let's be honest. I mean, they're the big two there, the big tyrants. Neptune as well, just sitting on the inner edge there. Not having too much. Neptune's probably been the quietest, safest place to have been in the system so far. Neptune has had hardly any interactions this whole time. It's been a very, very safe haven. It's still blending close to that Triton orbit, isn't it? There you go, on the inner edge of the Kuiper area, so pretty cool. Then Nemesis out there in the distance, waiting to clear anything up that gets caught out. So not good. So there we go. We can get a bit of evolved time now. I reckon maybe we'll see a few ejections here. Some of those dwarf planets may get caught by the Nemesis star. We will see as they fly around. I mean, there could be a few that get caught out by it, but probably not too many. Nemesis is still a decent distance away from the sun, so we're really not seeing too much chaos over there. Look at the Planet X orbit. That one's still changing, isn't it? That's going to take forever to return. You know, this orbit is now saying it's further out than the Nemesis orbit before it was cutting in, so it's completely out of the game at the moment. Right, back to the inner solar system though. We need to focus back on the sun now as time is changing. so we do need to continue the sun's age as well. So, here we are. We go to the luminosity, for instance. So I'm going to go to 1. I'm going to go straight to 1.1 here. And there we go. Radius. I'm going to go 1.1 as well on the radius. There we go. So bigger, slightly brighter. See how the sun does. Temperature is going to slowly drop. So more of an Alpha Centauri kind of star now, you know, get a little more powerful than the present day sun. So hopefully giving a bit of warmth to these inner planets that are in much need of some love. In Mars, still in the outer depths here, isn't it? Just needs that temperature to really get going. Right now, it's still just too far away to really get the good temperatures. It's got the conditions on it. It has the stuff. It just needs the warmth. Feya, again, a world that's always been a bit poisonous looking. It does have a bit of water in there, a bit of carbon dioxide, so maybe a bit of temperature. We may be able to see a kind of some sort of liquid on its surface at some point. Ceres as well, the only other inner planet. Minus 64. Doesn't have the mass, but it is a decent enough size to be, you know, a planet. So there we go. I mean, that can't be liquid water on it, surely? Water. No. Is that liquid nitrogen? No, it's frozen nitrogen. So it's all just frozen up underneath. If we have a look, there it is. Yeah, it's just that atmosphere making it look like it almost has oceans, but there you go. A frozen world. So it's just all the inner planets just need warmth. Just need a bit more sunlight to really get going. So let's continue. We can really crank it up now. There we go. Get a couple years simulated there. Look at the outer solar system. Oh my god. Saturn and Jupiter have completely calmed down now since the chaos by the looks of it. I mean, Saturn's orbit's barely changing now. Before it was a bit crazy when they were trying to eject the other objects. Oh, I saw the Planet X. Oh, there's the Planet X flying by. Hey, there you go. So it's still hanging on in there. But it's not looking good. Oh, yeah. Okay. Planet X. We're simulating a lot of time for that Planet X to complete a full orbit. So you can see the stability. The stability is really good now. I mean, you got the little wobble in the outer stuff. I mean, that's pretty expected. But, you know, everything is mostly staying where it belongs. Now, there's not really anything having crazy changes. So, there you go. Look at the Planet X orbit. That is fascinating how that's managed to hold on like that. Oh, is it slinging around again? Oh. The fact that it's managed to survive. Look at its orbit now. It's like coming back in. No way. If it actually survives. Oh! Nemesis! Look at the Nemesis damage. Nemesis. It had a spark of hope. And the Nemesis comes in and just absolutely slice and diced it and slung it back out again. Oh, Nemesis. What an animal Nemesis has just done there. What has it been? A true animal. Lured the prey in and then attacked it. There you go. Right. In the solar system, how are we doing? Mars and Feya. Still not many changes there. Mars is going to have quite the seasons with its approach like that. Having that closer and outer area there. That could be a costly error for the Martian surface. But again, well, we've had a lot of evolution time. We're going to continue with the sun. We're going to go 1.2 suns now. Slowly crank it up. I'm going to go 1.25 on the luminosity. So there you go. A little more of a warmth there. See, Mars is slowly but surely warming up. Feya, minus 24. Currently the warmest of the objects. There you go. Okay. The brightness is slowly going to get further out as well. But yeah, the zone is still very much in the inner system right now. Pluto, Eris. I mean, Pluto is a world to focus on in the far future because that does have all the conditions necessary underneath there, if I remember correctly. It did have the water, nitrogen, oxygen. It's got all the stuff it needs. It just needs the temperature. So the fully fledged planet of Pluto. And if we get a lineup of everyone going as well, just to get remains of what is actually in here. So there you go. So below Neptune, you've got the ejected planet X. Triton, one of the largest objects in here as well. Eris is also a very large rocky world. And you've got Feya, Pluto, Mars. Pluto's actually larger than Mars in this alternate reality. Ceres down here as well, the smallest of the planets. Not very large at all, looking kilometers. I mean, Ceres is borderline dwarf planet size. 1400 there, so not particularly too big, is it? I mean, Mercury is way larger than that is. So there we go. Mercury is 2440, so that's a 1000 radius smaller than Mercury is. That's not really. Maybe yeah. Ceres technically dwarf planet. Doesn't have the mass either actually, but it's still got more presence than its normal version. Look at the wobble there. That is brilliant. There you go. Let's continue. It's all about Planet X at the moment. I think just watching where that slings around. Oh, there you go. Oh, that may have killed it. I think Nemesis has finally got rid of him. It took long enough, didn't it? But yeah, the Planet X is never going to return from that. Now that is, yeah, that's at it. Surely, there's no way that's going to return. Look at this. This is cool. The trails. So you see, we are travelling through space. There you go. It's pretty cool when you look at it this way, actually. Normally you think it's just sitting still, but we are moving through space. There you go. Look at that. Everyone's slinging around. Very cool. But the Planet X is never returning now. Okay. So now we're moving into the future now. The system is stable. That was the last instability gone. Let's remove it. It is out of here. Delete any particles, excess particles. Okay, so there we are. Heading into the future. The stability is complete, and there you go. This is probably one of the first systems we've had that's actually cleared itself out naturally, and actually we haven't had any stellar encounters or anything we've thrown in. It's all naturally evolved to this point without any interference from us, which is cool to watch. Because originally it had a lot more stuff, so the fact that it's managed to clear out and keep the stability remaining with the other planets, the fact that they've achieved it like that is pretty cool. So there you go. It's just the inner system. I think the sun's gravity is so strong at this point in this region, though, that they're not going to have too much influence on each other. The Mars and Feya, their orbits seem pretty good, and we can look at their orbital stats here. I mean, I doubt we're going to see much. I mean, there'll be a few little changes, but look, the overall orbital time, it's not really having much of an effect, is it? So it's mostly, for the most part, it's pretty stable. Feya, same deal. Yeah, so they're pretty good. Very good. Okay. So again, we need to still crank the sun up here. We still need more luminosity to start seeing good conditions. So I'm going to go to 1.4 suns now, luminosity. We're going to go to 1.5 on radius now as well. So there we go. So a decent increase in size there. So we should hopefully start to see the warmth reach some of these planets now. No, Feya still not holding, still hanging on in there. Mars, -89. But we can start to see there is a slight change on the surface of Mars. You can see the red is starting to appear under that ice. Some of that ice is starting to depreciate. There it is. This weird orbit still is a bit of a weird show in there. Look, you can see the orbit is slowly but surely, but it's starting to melting some of that. There you go. It's got that weird Europa map mixed with it as well, so it's pretty cool. Oxygen. If we look at water, I doubt it's still frozen, isn't it? Yeah. Some of it in gas form. Carbon dioxide. Carbon dioxide is still frozen on Mars, so once that melts, that carbon dioxide could really crank this, give it a real atmosphere. So a little bit more temperature, and that carbon dioxide starts. You can see the carbon dioxide. It's all solid. Be more liquid into a gas. The carbon dioxide is slowly but surely liquefying on Mars. So a long enough time, and that carbon dioxide will continue to change. Look at that there. Ooh, or is it? It's going into gas. Look at the gas. There you go. Most of it's going to a liquid and then immediately going to a gas by the looks of it. Or is it? But yeah, I still think we need a little more influence from the sun to really get it going. Feya. -14. So again, the sun. Let's continue with the evolution. Let's go to 1.6. Then we'll go to 2 luminosity of sun. So we're starting to see a substantial size increase of the sun now. So we should start to see very shortly good temperature. Oh, there you go. Feya. Entering the positive temperatures. There you go. Mars. How are we doing at Mars? -79. So that's weird orbit. It's still been a bit of a pain for Mars. It just hasn't found its... The seasons on Mars can be pretty rapid once we do start to see positive temperatures. Right, there we go. So we're in the positive temperatures at Feya now. So we can go and have a nice looking surface for the very green sky of Feya. And there is your sun. So there you go. Slow down time. There you go. Ooh. Very fast. But a very cool green looking sky. There you go. Check that out. Sunrise. Approaching now. There you go. There's the clouds. The sun's coming. There it is. Sunrise. Very good. With the very green. The ultra green. Now, do we have liquid on the surface? So is the question. Let's have a look. Any liquid? There is liquid on the surface. Obviously, we made it very green. If we want to highlight it a bit more, is it there? Oh, that was ice. Hang on, was that ice? So that's ice. Snow. So it is mainly the liquid. So if we change the liquid colour, can you see it? I think it's all underneath all the ice still. Yeah, there is liquid there. It's just under the ice. So there is starting to get a bit of temperature there. We did make it very yellow looking though, didn't we? So it's quite hard to see. But there is the liquid. Very good. From the very, very yellow coloured Feya. Truly a world of mysteries. There you go. But still, the orbit is just not giving it, even at 2 luminosity. Even how far away is this? Because these are further than the Mercury, Venus, Earth orbits. These are 1.2, almost 1.3 year orbits. So, yeah, a lot further than the normal Earth is. So that's why we haven't yet received a temperature. Because, you know, in reality, the real Mars needs a lot more luminosity than 2 to really get going, I think. So, yeah, it's definitely why these guys haven't warmed up yet. It's because their orbits are pretty far. I mean, if we look at Mars's orbit, how far away does Mars go? 1.6 years. Yeah, there you go. It's still slowly warming up there. But again, we're mainly going to focus on the inner solar system for the time being because the outer areas achieve mostly stability. Let's go to 2 luminosity of sun there. Double the power. And there you go. Feya finally experiencing better temperature. Now Mars, still a very frozen ball, but wait till that carbon dioxide melts properly. See, 80% of the carbon dioxide is still solid. Hasn't become a gas yet. That is very, very bizarre. Slowly, look, it is warming up. Look at Mars. We're really seeing some changes now. As it gets closer to the sun, now it's really cranking it up. So every orbit, it's not freezing enough in its far away area, so it's slowly getting close enough to warm up. Look, and we're so close to getting the positive temperatures on Mars. And you can see on the surface, we are starting to see liquid water appear on that Martian surface. There you go. If we have a look down here, there it is. Just pause it there. There is liquid oceans appearing on the surface. So the highest area is 57. Really? That is quite a substantial temperature change. Look at it go. But the average is still very, very cold. So only some minor areas obviously getting that high level. That carbon dioxide is still in that Mars though, so we do need to see a bit more on that. Vegetation, if we switch it on, we'll see any areas that are habitable will go green now. So we can spot any regions. Right now, nothing. Same with the city lights. We'll turn them all on. If it becomes habitable, we will see the lights appear. Very good. Okay, so right now Mars. That orbit is still a bit of a costly one though, isn't it? There you go. And where's Feya? How are we doing at Feya? So 22. We turn on the vegetation and city lights are switched on at Feya. So is there anything going on at Feya? Turn off the atmosphere. Is there any lights? There is no lights. So the game does not think it's habitable at the moment. Vegetation. On and off. So there's nothing. What's the similarity stat? Let's have a look. Not very good. Now why is that? Is that the surface pressure? 700 ATM. Whoa! Really? 700? Would have thought the yeah, that's definitely not a life likelihood stat there. Where's our oceans? It should be on there. Oh yeah, they are there. Let's make the liquid a little more visible. No, it's still kind of hidden away, isn't it? It does. The game is saying it's got the liquid on it. Turn it on and off. You can see there are patches there. It's just they're not really showing up very well. Like you can't even see it. So it's still underneath all the ice. Yeah, there you go. It's all under that ice. That ice layer is still very thick on it. But it is there. There we go. If there's a lighter shade. So look underneath. That's the colour underneath all that. So yeah, that weird yellow ice is very strange. It's very strange indeed. So there you go. Feya. But yeah, world, it's probably going to become very Venus-y at some point, I reckon. Especially with that ATM on that. I mean, that atmosphere pressure is crazy. So Mars truly is the region you want to be looking at right now. It's waited a long time for this, Mars. It's been in the cold all this time since formation. This has got to be where it's at. Just coming out of its long frozen ice age. So there you go. So the water, where are we? Freeze. Yep. Where was the... A lot of it's still... So most of the... Yeah, okay. I think we can manually raise the seawater a bit because we do want it a bit higher than that, don't we? So surface. Give it a bit more sea level. Yes, please. Where are we? I can't actually see under the sun. Aha! That's there. The game's giving it the green now. Look. The vegetation is showing up. Very cool. Right, so let's give us our... Yeah, there you go. It's more like it. So it's a mix of Mars's and Europa's surface texture. So it makes quite an interesting dynamic, doesn't it? It looks quite good. But yeah, the game is giving it the green light for the habitable area. Look at that. Very, very cool. So right now, Mars is the place to be. City lights, if habitable, the city lights should be there. I mean, the game is giving it the green. It's very strange. Just give it a nice blue. And there you go. The habitable Mars has appeared. Slightly lower the thickness of that. There you go. There it is. So all naturally done it itself as well, without us influencing anything, which is pretty good. And there you go. Temperature is warming up now. I think it's because we changed the sea level a bit, didn't it? So it does kind of manually do it. How high does the average go? Remember, it still has that winter period where it goes further from the sun, so that balances out the temperature, because it does dive into that closer area around the sun there. If we go to the sun itself, so if we have a look here. So the closer region to the sun is there. Ah, it's not giving us the measurements. That's a bit annoying. Still? No? Ah, okay, never mind. I think we can see in the actual look in the orbital stats itself though. 0.9, the shortest distance. So it actually dives in closer than the Earth. And if you think about it, a 2 luminosity sun, if you're closer than the orbit of the Earth, you're going to get very hot. So because it goes out to 1.84, the furthest point, it balances it out with the seasons. So you can see the green changes. It looks like the green changes depending on where it is in the orbit. If we just turn off. Now that's a few simulated years. I think the green slowly changes depending on the seasons. Look at that. That's really cool. Very, very cool. So you can see the closer it gets in the summer, the green disappears, but in the winter, the green spreads. So Mars has got a very interesting dynamic at this point in time, and this would obviously keep going for millions of years. Obviously, we speed up time for the sake of convenience, but no, technically, this Mars will be like this for a long time. In this period, the sun's going to sit at 2 luminosity for millions of years as it slowly evolves longer. So Mars truly has become the world, despite all odds at the beginning as being the object furthest from the sun out of the major planets. The other 3 in the planets were habitable very, very long time ago before they got ejected very early on. I mean, the Earth was still in the snowball phase. The Earth never even got a chance. It was mainly Mercury and Venus that were the habitable worlds in this system's early days. But because they got ejected, they never got to truly live out their life because of the instability of the system. But so now this system is stable. Mars is the world you want to be at. And it is a very beautiful looking Mars as well. I think that's one of the best looking terraform Marses I've ever made. I like the mix of the green and the red surface changing. I think that's a really cool... The cloud colour, It's a good looking Mars. I mean, I'm just going to call that the Mars. May use that Mars in the futurist or something. So there we go. The Mars. Save that in time. There you go. That's a great looking Mars. Again, if you want to have a look underneath, that's what it looks like underneath. I mean, we can make it a little more custom. Slightly different ocean colour. Why not? There you go. Make things a little more interesting. Yeah. For the true sake of make it maximum custom, you can have different coloured oceans. So a nice 13 degree. I mean, yeah. I mean, if we look at the surface, so this is where you see the differences. Look at the hotter regions go out to the 50s. I mean, that's roughly what you'd expect on the Earth. I mean, some of the hottest areas on Earth go into the high 40s. So this is a little higher. I mean, the hottest recorded temperatures are around this, aren't they? So it's not too far off the present day Earth, technically, you know, with the average and the high and low areas. I mean, it's not too shabby, not too shabby. Then the cold goes to minus 94, so it still has more dramatic temperatures than the regular Earth in our reality. This one gets colder and it gets hotter than the regular Earth, but the temperature does change depending on where it is in the orbit. So there you go, Mars, looking very, very good right now, and there it is. It's come out very, very well with its pretty much 24-hour orbit, as you can see, or rotation, sorry. So very, very good. So Mars, no longer the red that it once was, now having a very nice green. As for Feya, on the other hand, the world that didn't get so lucky with its composition. It's got the temperature, but it is not a pretty sight. It is still a very toxic green appearance. Got Mars in the distance over there, not visible right now. But a world, or you can see, I think that is that, what's underneath? Can we finally see the liquid on it? No, I'm not so sure this ice is quite right. I think it should look more like that. I mean, I think it needs a full reset, this thing. I mean, it's a bit all over the place. Settle liquid. There you go. Maybe that'll help it. Oh, there you go. That's sorted out. I think it just needed this little settle liquid, or put the ice back on. Yeah, I don't think that ice should necessarily be... Oh, let's have a look at them. 29 degrees? Yeah, I don't believe the ice should be there. I'm going to keep the ice disabled. That's how Feya should look right now. But again, the high pressures here are just going to negate any chance for life. So there you go. There's Feya. Underneath all of that. But yeah, it's this stat here. That's where it gets you. The life likelihood is non-existent. It has this magnetic field. It's got the protection, but if we go back to the surface here, and we look at that atmosphere layer, I mean, look at the gigapascal. I mean, look, 786 ATM. It's a brutal atmosphere mass. The pressure on that is just wild. So just because it has the good conditions, you know, the pressure, too much pressure. So there we go. Pallas getting a bit of temperature. Look at that. Where's Ceres? Actually, let's see how Ceres is doing on the outskirts of the habitable zone. So world is still a bit too cold at the moment. But receiving a nice amount of luminosity. Actually, speaking of the nice view, actually, let's go back to Mars. Let's get a nice view of the sun from our very, very nice looking habitable world here. Let's go ahead and land on the Martian surface here. Or in the ocean at the moment. Let's go and land on the surface somewhere. Let's go there. There we go. That's better. Get a nice view of it. There you go. Let's have a full view. Have a nice looking rotate. There you go. Oh, it looks great. There we go. Let it come around again. There you go. There's your sun. So again, 24-hour day. Looking very, very good. There's it said. I love how the sun distorts behind the clouds as well. That's a really cool effect. So there we go. It slowly dims. There it is on the sunset. Martian sunset. Look, that's a great view, isn't it? Look at it. There you go. Oh, it looks good. And there it is. Very, very nice. Yeah, we like that. Oh, very good. Okay, there you go. So the beautiful Mars right now. Great, but unfortunately all things have to come to an end and we need to continue evolving this system. So now we're going to start seeing the opposite effect. The sun is going to continue on its process. It's going to go to 2.1 luminosity of suns now. We're going to go in for another save. There we go. Replace that. So we have that Mars saved in time in that other sim as well, which is good. So last modified. We've got the Mars edit there. Good. So now we're going to see the increase of Mars's temperatures. So if we look here, this is where things are going to become a problem. And if we look at the life stat, actually, it's probably the better. Here we go. This is going to be the problem now as we start to increase the aging. Look at that. Oh dear. The life likelihood is going up, but the Earth similarity drops a bit. Okay. But we are, yeah, we're going to start seeing the problems now of the increased temperatures. Even in the further part of the orbit, eventually is going to start seeing it. And you can see, look at it in the summer. Some of that did disappear there, didn't it? Oh, yeah. There's your stats. So it still changes depending on this orbital position. That's a real big change there. Ceres, how are we doing at Ceres? Still, is Ceres getting anything yet? No, still not here yet. Okay, Feya, 26 degrees. I still don't get how Feya doesn't have with that pressure. I'm surprised it doesn't have a higher atmosphere there. I think maybe the greenhouse effect's going to really kick off on that eventually. Maybe we'll have to give it some more layers just to really boost it. Because I think that should have a lot more. I mean, the regular Venus only has 91. This has way more atmosphere layer than that. So this thing should be absolutely just flinging in temperature right now. So Mars, still the place to be. So even with a bit of evolved sun, you know, Mars is still the place you want to be. It's still got the conditions. Just the summer may get a bit hot there, though. We're going into the 70s now. So yeah, stay away from the equator. The equator is a brutal temperature. Stay a little further north. Stay in the yellow. The yellow seems more nice. Stay in this area. Around the red. Don't go too cold. Minus 100 degrees. So the hottest has got hotter and the coldest has got colder. Figure that out. Has this orbit changed maybe? I don't know. Is this orbit further? I don't know if it's further elongated. I'm not sure. But Mars is still doing very well. It still looks great. Let's have a look. It was about 1.8. No, I think it's still the same, isn't it? There you go. There we are. The show must go on, though. Let's continue. The sun. 2.25. We're going to go up to 2.1 radius. So, again, bigger, scarier. There you go. Mars. Going to feel the pain now. 30-degree average, maybe, starting to hit. Temperature's still there, though. Still holding on. Still hanging on, old Mars, isn't it? I think that longer orbit is helping it out here. Feya. Starting to get hot. I'm thinking this is where we start, you know, I'm still surprised how its atmosphere layers haven't manually increased, I have to say. I thought this would have, I don't know if it too manually, start doubling it up now, because I think this should be a lot more dramatic than it actually is. Turn the infrared up. Maybe it's highly reflective. Let's have a look. Where's the stat? Is it there? 0.4. It's not the most reflective thing out there, but there it is. Yeah, this is going to be the greenhouse planet eventually. That's going to be Feya's going to be very hot. Mars 30 average, still surviving in there. Let's make, just so we're not giving it a bit of evolved time. Let's have it, crank it up for a while. Get some real years going there. Let's have a whole nemesis orbit of time. Mars is still hanging on in there. You know, there's no changes. There you go. There's not much going on in the outer regions. Everything's still too cold out there. But yeah, Pluto is a world I want to hopefully have a look at some point when we get there. So again, sun. Let's continue start evolving. Let's go to 3 suns now. We're really getting in there. 3 suns. There we go. Mars is now going to really feel it. Yeah, there you go. 40 plus 50. This is going to kill it. The 3 suns has done it. That's really done it in that 2.25 to 3. That's the killing pot. Or the killing point. Yeah, there you go. Mars, not looking so great now. 52 average. So if we look on the surface, 100 plus now. So that's going to start hurting. We're going to start to see the atmosphere change to a more yucky looking appearance. So there you go. Past its prime. No more green, I don't think, in the height. There's still a few bits of habitability. We've looked down here. There's a few green areas left. But, you know, the vegetation, it's not going to like that. 52 average. So the Mars is really going to... really feeling the heat now. So not so great on the colours no more. There you go. Back to the orange, the red. Fair. How are we doing over here? 113 degrees. That's where the global greenhouse kicks off, I think. It's starting to really feel the pain. So I think we're gonna activate that global greenhouse. We're gonna put up to 8 layers now. I think that's gonna really kick it off. I mean, that pressure should be having, yeah. Oh, that's got higher. That didn't used to be like that. That's not me doing that, is it? No, the layers don't make a difference on that. That's just generally evolved on its own to do that. So, Feya, a world that's about to go global greenhouse Venus mode. So, pretty wild stuff. Yeah, oh yeah. Now look at the temperature. Let's have a bit more of evolved time here, but there you go. That's going to really skyrocket now. Let's have a few years. It is increasing on its own. That wasn't me interfering. That literally was naturally evolving on its own as it got hotter. So Feya, the world of extreme pressure, 200 plus now. That greenhouse is really hot. So I think we're going to lose a bit of the greenness. It's going to go a little more yellow. There you go. So the Feya, not looking good. But where is Ceres in all this? We should start to see Ceres. 30 degrees. There it is. We've kind of passed the best moment for Ceres, but right now, there you go. 30 degrees average. Let's have a look at the surface. 50. I mean, yeah, it looks to be in a decent position. I mean, I don't think we're going to have much. I mean, no, it's got life likelihood. Hey, Ceres. Check that out. See the little dwarf planet. We'll turn those on. Bit of vegetation. Let's see. Is it mostly? I think it's all ocean, isn't it? Nope. It's a bit of land on it. Is that ice? Ice and snow? It is ice and snow, but if we look very carefully, if you just noticed. Aha! It's a Ceres. Also, I think this is the first time we've ever had Ceres actually get what it needs. And look at that. The vegetation is green. The game classes it as habitable. Very good. I mean, let's have a look. 10%. There you go. It has no magnetic field, though. Very good. Very impressive. There you go. Nice. So you go, Ceres. Very ocean heavy, but the poles are where you want to be. I mean, have a look here. Minus 49 at the poles, but apparently it's habitable, you know. So, I mean, just because humans can't live there doesn't mean life as we don't know it can't live there, right? We only know life as we know it. What about life as we don't know it? There you go. It's a Ceres. Potentially a life world there. Very good. Jupiter. How are we doing over here? Temperature. I'm assuming not much yet. Oh, yeah. Game has Jupiter has a lot of bands. Minus 120. Yeah, nothing at Jupiter yet. We're still in its. It's roughly normal 11 years. 5 AU. Nothing going on there. Saturn, same deal. Everyone else is too cold. So there we go. So we've passed the prime of the inner planets now. And the sun is going to start rapidly evolving. So we're going to go for an immediate double up. We're going to go to 6 now. Really start feeling the heat. Stun. We're going to go to free radius. There you go. Bang. And then go for a save. To make sure. Always save your games with the suns. There you go. There we go. Cool. Nice. Okay. Good stuff. So 6 luminosity of sun. So the power is really heating up now. Any temperature at Jupiter yet? Minus 100, no. But the inner system is going to be completely vanquished now. 113 at Vesta. Mars, 166. I think Feya is going to be really fit at 400. But yeah, Mars. Still, the water's almost completely gone. It's a wreck. It's a complete wreck. Nothing left. So I think, you know, that thicker atmosphere. You know, it did have more atmosphere than it does in normal. So a thickened atmosphere as well. Barren wreck. Ceres, 131. What's going on at Ceres right now? What is all this? What's all that material evaporating? What is that? Nitrogen? Water? Not sure why water's saying it's frozen. That's not quite right. Silica, it's all solid. It's only nitrogen and water at Ceres contains. That's some kind of nitrogen and water atmosphere being built there. Water vapor atmosphere. Some kind, I don't know. Nemesis, it's so small. I mean, this thing won't even evolve in the time the sun evolves. I mean, it's so dim. I mean, this is barely going to have any evolution at all in the sun. I mean, there's a red dwarf. The red dwarf barely ages in the time the yellow dwarf, sun, and G-type star ages. So, the Nemesis will see no changes throughout this simulation, really. It's just going to be chilling there the whole time, just on the outer edge. Let's continue evolving. The Mars orbit is changing. Look, I thought it was changing earlier. It is. The Mars orbit is still having effects. Yeah, there you go. So the Mars orbit was never perfect. I mean, it's still changing. I think that's Feya just slowly tilting it around there. I mean, it's just moving it. The distance doesn't seem to be changing. It's just, it's kind of like Mercury in our normal solar system. It just slowly bounces around the sun a bit, doesn't it, Mars? Yes, it just goes around the sun a bit. You can see it does extend into the Ceres area. Yeah, that region. Ceres orbit still changes. There's still a few. You can see over a long period of time. I think Jupiter still has a bit. I think Jupiter's tug is still pulling on those a bit, so it is still having a bit of an effect. And maybe Jupiter would eject one of these eventually, with enough time given. So there's still a few changes in the inner system, isn't there? There you go. Outer system. Oh, what was that? Something's gone. Was that Mars and Feya? It was. I think that was because we're running the simulation a bit too fast, though. Personally, I think that's why that's done. Because normally, if you do it, things get a bit wild. But their orbits were changing a bit, so I mean, it's not out the question that they could have been ejected eventually, because they were wobbling. We did see them wobble, so maybe they completely go. But for the sake of a bit more drama, we will go back. Because sometimes when you run the simulation first, the results are not as realistic. So there you go, back to where we were. So it's back at 6, isn't it? But those orbits were changing. I mean, let's just go and actually analyse. Just keep an eye on that number. Put the goggles on, off. There you go. Yeah, that's better. So I want to repeat. I actually want to rewatch that. Because that Mars orbit, look, it was moving. Look, it was constantly changing. These stats here were changing constantly. Look. And this is a lot of... Look, we're doing, there was 1,000 years of generated time going on at once here. That's a lot of time passing. And with enough given time, you know, it can happen. And Jupiter definitely is having some kind of pull on that. It was a bit weird how Feya went out with it, though. There you go. Yeah, it really was a... I'm not doing it as quick as we were, so we get more realistic results, but... There you go. The Mars orbit was changing constantly. There was definitely some problems going on there. Because before we were running it like this, weren't we? Like really fast. Like the quickest it could go, yeah, about 700 years a second there. So it was taking a long time for Mars's orbit to go around the sun like that. So pretty wild. But yeah, so we negate that. We're going to continue the sun's evolution. So we're going to go luminosity. We're going to go to 12 now. We're going to really buff things up. Then radius, yes, we're going to double that up to 6. So the sun is really, really getting in there now. Things are getting dangerous. I mean, if we go into AU now, 0.02. The sun is getting fierce. Into the red giant branch, probably at this point. And luminosity is going to start really feeling the power. Jupiter. Maybe we start seeing temperature over here now. Yeah, warming up a bit. Okay. The inner system is a complete wreck at this point. What I'm going to do, though, I'm going to disable... One thing I've found out, I was talking to one of the Universe Sandbox team, and sometimes when the star puffs up and down and does weird stuff, if you disable collisions, fragments, that supposedly will stop that happening somewhat. So we will see how that behaves. Less particles generated as well, so we'll see. Oh, hello, what we're doing over here. Oh, there we go. So they're definitely disabled. Yes, they are. Let's see if that makes a difference in this scenario. So there we go. So sun. Because sometimes the sun goes weird when it ejects mass and then it gets the mass back. And it just repeats and it puffs up and down, does all weird stuff. So in the game. So we'll see. Hopefully that behaves. What's that orbit there? What's that? Is that an ejection? One of the dwarf planets has been ejected. And it's now got an orbit that's going to spiral into the inner solar system here. If it makes it in there before Jupiter or Saturn eats it up. So let's see how that does. Or Nemesis is going to definitely chomp it up. Oh, very good. Is it going to sling round? There you go. It's coming in. It's going to be the first visitor to the inner solar system for a while, possibly. Or is it just going to go between Jupiter and Saturn? So this star, this dwarf planet gets its time in the sun between Jupiter and Saturn's orbits, getting a real blast of that sun there. There you go. Oh yeah. Okay. Pretty rapid stuff. Okay. Looking good. So that's going to sling out again. But yeah, there we are, everybody. That's going to do it for today's episode. Things are getting extreme now. So the orbit, yeah, the orbits all calmed down. But sun's got its job to do now, and it's get older in age. So next episode, we're going to see the destruction of this alternate reality. So if you enjoy this video, everybody, make sure to press that like button and subscribe for more. Help us on the journey to 50,000 subscribers, as we are less than 2,000 away now. We're really closing on it. I cannot thank you all enough for your support, everyone. It means the world. I'm glad you enjoy my stuff. Let me know any thoughts and feedback down below in the comments as always as well. And yeah, everybody, with that all said and done, make sure you have a great day, stay safe up there, and I'll see you in the next video. Goodbye.